just take the whole thing. Okay, so you guys will kind of want to see on this side over here, because everything's going to happen sort of here. I'm sorry, I've only got one of these. They're really expensive. This is made at the University of Wisconsin by a bunch of students, and this is our ant farm. So we're going to do some modeling of groundwater with this thing. And like we were saying, groundwater's understanding its flow is really important in terms of like understanding how pollution affects things and kind of like how we can build wells properly, stuff like that. But let's go ahead and start modeling some things. The first thing I'm going to do is add some water. So this over here on this side is like the recharge zone. So on your papers as you're going, go ahead and write down label the parts of the ant farm. Okay, that'll help you on the quiz because I'm going to ask you questions about different parts, and I'll kind of point them out as we go here. But this is the recharge zone. So just like we were talking upstairs in the lecture, water is falling, maybe this is far away, and it's falling into this part of the ant farm, and it's slowly going to move through this and out the other side. Okay, the reason it's going to move has to do with the water table. But I guess before we do that, let's point out some of the pieces here. There is a coarse sand wedge. So we're going to try and model how fast water moves through the coarse sand. The rest of this is very fine sand. Okay. Down below, there's a confining layer. So this is what we were calling the aquitard. This slows the motion of water and stops it, impedes it entirely from here. So we're going to see how well that works. It shouldn't allow water to go through it right here. Down below, there's some more coarse sand. We've also got a landfill, happens to be a little leaky. A lake here, which is slowly filling up with some water. And then a series of wells we've drilled. If you can maybe label some of the wells, especially the Artesian Well, which is D over here. This is our Artesian Well here. And we even have an artesian spring that we're going to see in the bottom of the lake. So this opens up into the bottom of the lake. Okay, so label that as well. You got the landfill, the lake, the artesian spring, the Artesian Well, which was right here that somebody drilled. And then we've got another series of wells, a bunch of other wells over here that have been drilled down, and we're going to kind of see how the whole thing reacts. But first, let's draw the water table. Okay, see if I can do this here. So it's kind of easy if you look at where it's at in the wells. I can see it there and there and there, and it's changing, so it's a little hard to follow. There's a little air bubble in that one there. It's easy to see here because it's the actual level of the lake, right? I have to kind of guess over here, but I can see it in the wells. And in fact, over here, it's all the way, should be up to over that direction. There it is over here. Oh, my pen got wet. There we go. So if you look at this level, the water level here, the pressure, raise that back up a bit. You see it kind of shoot up.
Oh, the lake's moving up.
It's moving right up. So as it goes, notice how it's higher over here and it gets lower over here. It kind of slopes. Okay? Because it slopes, there's greater pressure here than there is here, which is going to cause all the groundwater to move this direction. So no matter what happens here, it's going to move that direction, which has huge consequences. If we spill pollution over here, somebody who's living right here has no problems. But somebody who's living here could have huge problems. So let's model some of that out as we go, if you guys get those parts labeled. Number 3 there on the next page is talking about the incline. I just drew that water table in there, and it's changing rapidly. Depending on how much water comes in over here, it moves, right? But it's higher on one side than it is on the other, and that's what makes it flow from high pressure to low pressure. So now let's look at the aquitard down here. If this thing's working, it ought to keep anything from up top going into it. Now, obviously, the recharge zone for it, it can get in right here. So all through over here, water's capable of flowing, but this should prevent it. Now, I've got a well over here that is drilled down. I'll get my, there it is. Got a well over here drilled down. Let's see if we put some poison here in well B. Let's see if it can get through that confining layer. Let's see if it can get into that aquitard. There we go. Oh boy. Look at all that toxic stuff. Somebody just pumped some really bad stuff down their well.
Oh, wow, you can see it.
Ooh. Look at that pollution plume down there. Notice it couldn't get through this. It won't go through this. This is keeping out. This is a layer of clay. Works really, really well as a confining or an aquitard layer. But we're going to see this move. In fact, I'm going to put a little line on it. I want you to pay attention to which direction it goes. There's the original plume. As we go, see if you can figure out how that's going to move. Because we have higher pressure here, it should be obvious which way that's going to go. Okay.
Wait, the lake's getting yellow.
The lake's getting yellow?
Does it? Is that just my imagination?
No, I think it's your imagination at this point.
Oh, I saw the
We
yellow
haven't
on
done
the
anything to the
beaker.
lake yet. Hopefully we haven't done anything to the lake yet. So when we're moving here for number 5, we always move from higher pressure to lower pressure. Okay? If I raise that up, you can actually see how much higher the pressure is over here. Okay, so let's say a chemical spill. Somebody does a bad thing and spills chemicals. Lost my syringe. Oh, right there. How about that? And spills chemicals on the surface. Bad, 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 bad. Somebody just dumps some chemicals up here. Oh, it's horrible. Look at that. So, what wells are at risk here?
A, B, and C.
Yeah, these are at risk. Do you see any wells that are no longer at risk, that still aren't going to be problematic here? Yeah, so D goes down, is an artesian well. It goes down below our confining layer, right? So some of these won't be a problem. Now what happens when it rains? Well, that makes it worse. Now it's really going to move around. Should have quite a bit going now.
It goes to the leaking landfill.
Right? Yeah, we've got actually making it worse in our landfill, right? Okay. Okay, while we're watching these plumes move, is this one moving down here yet?
Yeah, it's
A little
moving
bit.
this way.
Should be going that way because we have higher pressure here than we do here. Let's do an experiment and see what it's going to move faster through. Do you think that the pollution will move faster through the coarse sand or through the fine sand?
The fine sand.
The fine sand? Let's give it a shot here. We're going to go ahead and pollute this. Somebody did another bad thing. I got to figure out which wells I'm talking about here. We want 3 and 2, I think. 3 and 2. Yep. Okay. Here we go. Is it coming out yet? Oh yeah, so we're in the fine sand. We just polluted the fine sand. We're giving it a head start. Okay? Now we're gonna put some into the coarse sand, that white stuff.
Oh, wow.
Doing it at the same rate, and I'm trying to put about the same amount in. So we're gonna watch this for a second here, and we're gonna see which one moves the fastest between the coarse and the fine. There should be very quick, there should be a very noticeable difference here.
The coarse sand.
See how quick the coarse sand's moving? That's gonna be an answer to one of your quiz questions. It moves the fastest through the coarse sand. Think about it for a second. The pore spaces are bigger in that coarse sand. It can more easily go through. The fine sand's packed more tightly together. It's harder for it to get through. So it's gonna move faster. It's gonna be very noticeable. I can see it on my side. It's moving, right? Those were side by side when I put them in. So the coarse sand moves faster, okay? Has the greatest porosity and permeability.
Which question is that?
That was number 7 and 8.
Okay.
Okay. Number 7 and 8 are kind of similar. Now, it just so happens that a very, very naughty Elmo is driving around with a truckload full of some really nasty toxic waste.
Elmo,
And
why?
Elmo, I don't know why Elmo, come on Elmo, is going to dump it into our landfill.
He's lost
Oh!
He's lost his mind.
Elmo,
Elmo's gone
why?
insane.
Why Elmo? Oh, Elmo. Ugh.
Love how we used Elmo.
Now this happens with landfills. Like they have to line landfills because that stuff will leach out. In fact, there's test wells all around every landfill where they constantly monitor water flow. Because if that gets into the water, they need to alert people fast. Like, that's some toxic stuff. I don't know what Elmo just dumped, but it's got to be bad stuff. So it rains, and when it rains, all of that stuff in that landfill is going to go into the groundwater if it's leaky. Now, they line these things with clay. Bloomington made a big mistake. They lined their landfill with ground up tires, and it caught on fire.
Oh.
You know how hard it is to put out a landfill tire fire? Oh, millions of dollars is a major, major problem. And so they spent a bunch of money trying to fix this problem, because it's, you know, it's very dangerous to have your landfill leaking everywhere and on fire. So you can see what this leaky landfill is doing to our environment here, right? So let's think about which wells we'd want to drink from if that landfill was leaking like that.
D.
If you look at them, D is still cool. I'm totally safe if I'm drinking out of D. That water is going to just pass right by it. Okay, I don't think I'd drink out of the lake anymore here in a few. Any of these other wells are going to be super dangerous to drink out of. Not this one here is going to be okay. This one here is, the Artesian Spring's going to be all right, but the lake's going to be polluted here real fast. You can already see that stuff migrating across here. Right, look how far our yellow plume is there. It's really starting to move. Okay, so let's take a look at the artesian system. Okay, let's consider a new scenario where our artesian spring can get polluted. Okay, so I'm going to put some pollution. Some horrible individual decides to dump something down their well, tries to hide their pollution by pumping it underground. This has happened. People have tried to hide their pollution by pumping it into the ground to get it away so that nobody can see it. Okay, so we're going to go ahead and pollute our artesian system. Oh, who would do this? It's just disgusting. Makes me never want to drink water again.
Oh wow, that moved fast.
So that's all coarse sand down there, so it's going to move pretty fast, right? I'm going to go ahead and put quite a bit in here.
Oh no.
Because I really want to pollute it. I don't really. But I want to see what's going to happen. Now this is going to take some time. Remember, in reality, this can take hundreds, thousands of years for groundwater to move very far sometimes. So we're going to have to kind of come back to this in a minute and look at it. But I want you to think to yourself here, what's going to happen? It's going to get to this artesian well, right? And because this is an artesian system, it's not just going to sit down there, it's going to start to rise up this thing. Not so much so because this end of this pipe comes out higher than the top of the water table over here. However, do you see the top of the artesian spring? It's inside the lake. So that means that it's well below the water table, which means that the pressure should be higher under here. What's going to happen when that blue hits right there? It's going to come all the way up and spill out into the lake. It should anyway. So we'll try and come back and take a look at it later, but it's going to, because of the pressure, it's not just going to sit down there like it might in this one. It's going to hit this and it's going to come up and squirt out into the lake. Now it's not going to be shocking like woo, but it's going to spill out and it will definitely turn that lake blue. But we're going to get a blue-green here at this point now, right? So we're going to let this run for a little bit and we're going to come over to the other part of the lab. So why don't you go ahead and hit the stop